Okay, in this new lesson, we're going to be looking at this new concept of a logarithm. We're going to learn what the purpose is, what the definition is of a logarithm, and we're going to learn how to convert between exponential and logarithmic form. Okay, so we've been looking at exponential functions. Exponential functions, if you can remember, we have a base, and the x is in the exponent. So 2 to the x power, e to the x power, 1/2 to the x power. These are all exponential functions, and they have either some sort of growth or decay type of graph to it when we graph them out. Now, when we had equations like this, y is equal to x plus 2, we can do some rearranging and solve for x. When we had something like y is equal to 5 times x, we can do some rearranging with division, and we could solve for x. But in the case of these exponents here, how do we solve for x? We can't divide, we can't add or subtract anything to get rid of this 2 here. And how do we solve for x? What do we do? So in mathematics, or what we've decided to do in math, is we've created this function called the log function, and it is the inverse function of the exponent function. So here is the equation. Y is equal to b to the x power in exponential form, and we call b the base. That's why we use the letter b. Now in log form, we use the log function. Log is a function. It's the name of a function that is the opposite, the inverse of the exponent function. And so it's written like this, where we have log base b of y is equal to x. And that's how we say it, log base b, log to the base b, log to the base b of y is equal to x. And so the b is down here, and you can kind of see this idea. B to the x power is equal to y. So now, up here, we can solve for x in all these cases now. We have log to the base 2 of y. That's going to be equal to x. We have log to the base e, and we have log to the base 1/2. And so again, you can kind of see this 2 to the x power, e to the x power, 1/2 to the x power is equal to y. So that's the whole concept of a log. It's the opposite function, the inverse function of the exponent function. So here's some word analogies. We have addition, we have subtraction. We have multiplication, the inverse is division. We have exponentiation, the inverse to that is the logarithm. So here's some conversion examples. 2 to the third is equal to 8. We can rewrite that in log form. Log base 2 of 8 is equal to 3. So we have 2 to the third power here. I highlighted that. That's the way I think of it. Here's my base, and here's the exponent. 2 to the third power is equal to 8. We can turn all these other ones in the same exact way. Now you notice here's some special ones here. 4 to the 0 power is equal to 1. We know that. So we have log base 4 of 1 is equal to 0. And that's true in all cases. For whatever base we have, the log base b of 1 is always going to be equal to 0. We also have another kind of identity, that the log to the base b of b itself is 1, because b to the first power is equal to b. We have b to the 0 power is equal to 1. So now when we evaluate logs, let's look at this. How do we evaluate log base 2 of 8? What is that equal to? It could be very tempting to just do some division in your head. Oh, 8 divided by 2, but we need to think in terms of exponents here, not in terms of multiplication and division. This is what we need to think. We need to think 2 to what power, so 2 to what power here is equal to 8? Well, 2 to the third power is equal to 8. Here's another one. 5 to what power is equal to 25? Again, don't be tempted to divide here. It's so tempting. Your mind will just think of 5 when you see this written like this. But it's really 5 to what power is equal to 25? And of course that's 2. 5 squared. Here's a little trickier one. 3 to what power is equal to 1/9? Well, that's quite weird. Let's just think about that for a second. Well, I have 3 to the negative 1 power, that's equal to 1/3. So then 3 to the negative 2 power is going to be equal to 1/9. So that means the log base 3 of 1/9 is negative 2. Finally, we just have some shortcuts of writing things. We call the common log log to the base 10. So instead of writing log to the base 10, we just write log of x. And when there's no number here, it implies a base of 10. Because 10 is a very used log base. We also have the natural log. As we found, e is the natural base for exponential functions. So instead of writing log e all the time, we've abbreviated that with a shortcut. ln stands for natural log. The natural log of x is what that means. So as the final exercise, go ahead and try doing this. Try evaluating all of these without a calculator.